All right, so we've touched on this a little already, but now we're going to dig deeper into it. What happens at temperatures between the solidus and the liquidus? Right? Imagine you have a rock at some given pressure. You heat it up, it gets hotter and hotter and hotter. It crosses that solidus, it starts to melt, but it hasn't crossed the liquidus yet, so it's not totally melted. What's happening in that area? Right? It starts to melt, but it's not totally melted. Well, a lot happens at that point, and that's one of the reasons that our igneous rocks are so different from each other. Okay. But one of the things that happens is what we call partial melting. And it means that, again, part of the rock melts before the other part. And the part of the rock that melts first depends on the mineralogy. Some minerals have a lower melting temperature than others. For example, silica-bearing minerals have a lower melting temperature, so they start to melt first. That means if you melt a rock, when it's partially melted, the liquid, the magma, is going to have a lot of silica in it that melted first, so it's going to be felsic, whereas the rock that's left behind, the solid, will have lost the silica at that point, so it's going to be relatively mafic, right? So let's say you start with an intermediate rock, it partially melts, you get felsic magma and a mafic rock, right? Because of that partial melting. And this is described by Bowen's reaction series. Bowen's reaction series just lists out a lot of very common minerals and orders them from lowest melting temperature to highest melting temperature, right? The lowest melting temperature, those are those felsic minerals, the ones with lots of silica like quartz, muscovite, potassium feldspar. They're going to be the ones to melt first. But likewise, they're going to be the ones to crystallize last, right? So if you start with a rock and you heat it up to form a magma, the felsic minerals melt first. But if you start with a magma and cool the temperature to crystallize it back into a rock, the felsic minerals are going to crystallize last. And the mafic minerals will crystallize first. So those mafic minerals are like the olivines, the pyroxenes, the calcium-rich plagioclases. They're going to be the first to crystallize. Right? So we can now answer that question we had before. Why is the composition of igneous rocks that crystallize in the crust different than their magmatic source and the mantle? Well, it's because of partial melting and fractional crystallization, right? Partial melting produces a relatively felsic melt from an ultramafic rock. That ultramafic rock in the mantle, when it partially melts, produces a felsic magma that will rise through the crust, eventually creating felsic granite.